Firstly, we must create our node class. This has two attributes. Firstly, we have data in this case, of type integer, and then we have next of type node. This points to the next node in the linked list. Secondly, we have our constructor. We have two parameters here, data of type integer and next of type node. This will just be the attributes of our node class. Now this is our linked list class. It has one attribute of type node. This is the head node. It stores no data and simply points to the first node of our linked list. We instantiate an empty node as our head. Next, we have the constructor that has no parameters. Following that, we have multiple public methods. Firstly, we have our public method nextIsNow, which requires a parameter of type node and returns a Boolean. Basically, this checks if the current node is the last node in the linked list. Current.next refers to the following node, the node that current points to. If this is null, meaning it's the last node in the list, then return true, else return false. Next, we have the traverse list method. This is to output all the nodes in the list. It does not return anything. We start at the head node and we call this current. We now use the previous method to check if the current node is the last node in the linked list. Using a while loop, if nextIsNow returns a false, it will print the data of the next node and it will move the current to the next node, moving current along the linked list. Once there are no more nodes after the current node, the loop stops and the data of all the nodes would have been outputted. Following that is the add node method. It requires a parameter, which is a new data to be added to the end of the linked list. To ensure that the node added goes to the end of the linked list, we use the same loop to traverse to the end of the list. It will end with current as the last node of the linked list. Once the loop stops, add the new node with the data from the parameter. We add this at current.next, meaning the last node will point to our new node, making our new node the last node of the linked list. Another method we use, which returns a Boolean, is inList. This method checks the list to see if the data in the parameter is already in the linked list. Once again, it traverses the linked list using the while loop and the nextIsNow method. However, this time, it checks if the data of the current node is the same as the data in the parameter. If it is, then it returns true, meaning that the data is already in the linked list. If it reaches the end of the loop and the end of the list, and it has not yet returned true, then it will return false, meaning the data is not in the linked list. Finally, there is the remove first method, which simply removes the first node of the linked list. We take the pointer of the head node, which points to the first node, and we change this so that instead of pointing to the first node, it points to the first node's pointer, meaning the second node. This ultimately skips the first node from the linked list, so it is deleted from our linked list. Before we get into coding, here is a diagram of a linked list. We have a header, which has no data and simply points to the first node of our linked list. Each node has data and next, which points to the next node in the list. Once it gets to the last node in the list, the pointer points to now. When we remove the first node of a list, we change the header so that it points to the second node instead of the first node, thus getting rid of the first node from the list. Here is an example of traversing a list. Here they call the variable node TMP, whilst we have called it current. TMP starts at the head node. Keep in mind that the data for the head node is null. Each node has a pointer to the next node. Just like our code, a while loop is used, so that while TMP is not null, TMP is TMP.next, or the next node in the list. And as you can see here, the TMP, which is this line, traverses the list. This will continue until the node is null, meaning it has traversed the entire list. Let's try coding this now. First, we need to create an instance of our linked list class. We will call this test. And once we've done that, we can use all of our previous methods, such as traverse list. And if we run traverse list, it will output nothing, as at the moment there is nothing in our linked list test. There we go, nothing is outputted. But let's say now we want to add a node, for example 2. If we run this, it will output the number 2. Now let's say we want to add a couple more nodes, such as 3 and 5. It will add these nodes in the order in which we coded them. So it will output 2, 3, and then 5, as shown below. Now that we have a linked list with a few nodes inside, we can try using some of the other methods. For example, in list. We can test to see if 5 is in the list. If we run it, it will first output 2, 3, and 5, as we have our traverse list method here, and then it will return true, as 5 is in the linked list. However, if we check if 7 is in the linked list, which it is not, once again it would output the linked list 2, 3, and 5, but then it will output false, as 7 is not in the linked list. Now that we know that 7 is not in the linked list, we can always add this to our linked list, and it will output true instead of false. As you can see here, it outputs the list 2, 3, 5, 7, and true. Finally, we can use the public method remove first. By doing this, it will remove the first node in our list, which in this case is 2. So if we traverse the list before and after, it will show how the list has changed. Before we remove the first, it will output 2, 3, 5, and 7, and after we remove the first, it will output 3, 5, and 7, as shown here. And that is how you code a linked list.